Welcome to our continuing series on Alberta Science Outcome 9C3. In this video, we are going to focus on the transfer of materials. In this video, students will describe mechanisms for the transfer of materials through air, water, and soil, and identify factors that may accelerate or retard distribution. Introduction. The transfer of materials through air, water, and soil is a fundamental process in the environment. These mechanisms help move substances such as nutrients, pollutants, and particles from one place to another. Understanding how materials are transported and what factors influence their movement is important for studying environmental science, pollution, and even agriculture. Air. Materials can be transferred through the air by several processes. One of the most common is diffusion, where molecules move from an area of high concentration to an area of low concentration. For example, when someone sprays perfume, the scent molecules spread out in the air by diffusion. Another important mechanism is advection, which involves the movement of materials by the bulk motion of air, such as wind. Wind can carry dust, pollen, smoke, and pollutants over long distances. For example, wildfires in one region can send smoke particles across provinces or even countries. Deposition is another process where particles in the air settle onto surfaces. This can happen through gravity, called gravitational settling, or when rain washes particles out of the air. That's wet deposition. Water is another major medium. In water, materials are transferred mainly by diffusion and advection. Diffusion in water works similarly to air, but it is usually slower because water molecules are packed more closely together. For example, if you add food coloring to water, it will still slowly spread out by diffusion. Advection in water occurs when currents or streams move materials. Rivers, lakes, and oceans all have currents that can carry dissolved substances, sediments, and pollutants. For example, a river can transport nutrients from farmland downstream to a lake. Suspension is another mechanism where particles are carried by water without dissolving. Sediments like sand or silt can be suspended in water and moved by currents. Soil is our next medium. In soil, materials move through diffusion, advection, and percolation. Diffusion happens when molecules move from areas of high concentration to low concentration within the soil pores. Advection occurs when water moves through soil, carrying dissolved substances with it. Percolation is the process where water moves downwards through soil due to gravity, carrying such materials as nutrients or pollutants. This is important for groundwater recharge and can also lead to contamination if harmful substances reach the water table. Bioturbation is another mechanism where organisms like earthworms mix the soil, helping to move materials vertically and horizontally. Factors affecting distribution. The speed and extent of material transfer depend on several factors. Some factors can accelerate or speed up distribution, while others can retard or slow it down. Here, retard, we are using the short E sound, the R, more like a short U. We're only applying it to inanimate objects, never to human beings. Now, factors in the air. Wind speed. Higher wind speeds increase advection, moving materials faster and farther. For example, strong winds can carry dust across large areas. Temperature. Higher temperatures can increase diffusion rates because molecules move faster. Humidity. Moist air can help certain particles stick together and settle faster, while dry air keeps particles suspended longer. Particle size. Smaller particles stay suspended longer and travel farther, while larger particles settle quickly. Factors in water. The current speed. That's not the speed now, that's the speed of a river current or an ocean current. Faster water currents increase advection, moving materials quickly downstream. Temperature. Warmer water increases diffusion rates. Turbulence. Turbulent water mixes materials more thoroughly, increasing distribution. Solubility. Materials that dissolve easily in water are transported more efficiently. Particle size. Fine particles stay suspended longer, while larger particles settle faster. Factors affecting soil. We have soil porosity. Soils with larger pores, like sandy soils, allow water and materials to move quickly, increasing percolation and advection. Soils with small pores, like clay, slow down movement. Remember, pores are holes, similar to pores in skin, but in soil. Soil moisture. Wet soils allow materials to move more easily, while dry soils can slow down movement. Organic matter. Soils rich in organic matter can hold on to materials, slowing their movement. Biological activity. The presence of organisms like earthworms can increase mixing and movement of materials. Compaction. Compacted soils, or soils that have been stomped on to squeeze the air out, compacted soils have fewer pores, slowing down the movement of water and materials. The mathematical representation. This is going to get more and more common in science as you go further through. The movement of materials can often be described using mathematical equations. For example, the rate of diffusion can be described by Fick's law, where J, that capital J, is the flux, the amount of material moving per unit area per unit time. Capital D is the diffusion coefficient. That will vary for each soil sample, each material, each river. And delta C over delta X is the rate concentration changes over distance. So that triangle, that capital Greek letter delta, always means change in. Capital C is concentration, lowercase x is distance. So the flux is the negative of the diffusion coefficient times the change in concentration over the change in distance. Advection can be described by J equals Vc, where V is the velocity of the moving medium, air, water, or soil, and C is the concentration of the material. If velocity is an unfamiliar word, it is speed with direction attached. So instead of the speed of traveling on the highway at 100 kilometers an hour, you could have the velocity of going 100 kilometers an hour northward, or 100 kilometers an hour south. It's not a huge distinction at the grade 9 level, but it will start to be in grade 10. In conclusion, the transfer of materials through air, water, and soil is essential for many natural and human-made processes. These mechanisms include diffusion, advection, deposition, suspension, percolation, and bioturbation. Factors such as wind speed, water current, soil porosity, temperature, and biological activity can accelerate or retard the distribution of materials. Understanding these processes helps us manage pollution, protect the environment, and improve agricultural practices. Let's check for understanding. You are encouraged to pause and take time to think about each of these questions before the answer is revealed. Which of the following is a primary mechanism for the transfer of materials through the air? Is it evaporation, filtration, sedimentation, or wind? It is wind which drives advection. What factor primarily affects the rate of material transfer through water? Soil porosity, water current, water temperature, or wind speed? Pause now if you need more time. Water current. How does soil porosity influence the transfer of materials through the soil? Higher porosity decreases the transfer rate. Higher porosity increases the transfer rate. Lower porosity increases the transfer rate, or porosity has no effect. Pause now if you need more time. Higher porosity increases the transfer rate. Multiple choice test taking tip here. If higher porosity decreases the rate, lower porosity would increase the rate. So our first and third options are either both true or both false. If you can only pick one answer, that eliminates both. Which factor can accelerate the distribution of materials in the air? Is it high soil porosity, high wind speed, low humidity, or low temperature? Pause now if you need more time. It is the high wind speed. Which combination of factors would most likely retard the distribution of materials through soil? Would it be high wind speed and low soil porosity, high water content and high soil porosity, low soil porosity and low water content, or low wind speed and high soil porosity? If you need more time, pause now. Low soil porosity and low water content would be the ones that slow it down. Low porosity means there's fewer paths for the materials to take. Low water content means they're less likely to be picked up and carried. If you have any questions or feedback on this video, please leave them in the comments and I will try to respond to them in a timely fashion. I also apologize for any background noise you may have heard. I am recording this in a room under my daughter's bedroom.